So here we are studying what? Circular turning on road. Okay. In circular turning of the road, we will study two parts, on the plain road and on the inclined road. You have seen on the highways we have like this also, little bit tilt. While rotating, while turning, road will be little bit like this. Why it is, we will study here. Okay. So first on the plain road, but you are on the plain road only, but you are rotating. Okay. Then what we have to do is, now in that also, on the plain road also, we will make two cases, going with a constant speed and going with speed changing while turning. Okay. While turning, if you change the speed, what will happen? If you don't change the speed, what will happen? So if you are not changing the speed and you are turning on a circle, what will happen? You are going with a constant speed. So on a circle, like that part, that circular motion is whatever road is there, that road is a part of a circle, right? That is an arc. That's a part of a circle. Okay. Now to move on that circle, you need what? Centripetal force. Okay. So only who will provide you the centripetal force? First of all, normal is equals to mg. Okay. Flat road, na? So downward, upward normal, downward mg. Right. So normal equals to mg. And while you are rotating, that time who is providing you the centripetal force on the road, the flat road? Friction. Okay. When you are rotating on the road, who is providing the friction? Sorry, who is providing the centripetal force? Friction. Okay. So friction will be mv square by r. Friction have only one work, to rotate you around the circle. Okay. If you are going with constant speed. So something like this. Okay. You are rotating here with constant speed. Okay. Normal is outward, mg is downward. Okay. So this side friction have to act to provide you the centripetal force. Okay. Now what will happen is, as you will increase the speed, friction equals to mv square by r. If you increase the v, friction required is increase. Like if you want to rotate in that particular circle, okay, if you want to rotate in this particular radius, we have to increase. If you increase the v, let's say you are going with, instead of 30 km per hour, you are going with 60-70 km per hour, right? But you want to rotate your bike, right? Then you need high amount of friction. This force, this value increase. So friction should increase. Which friction will act? Static. Static maximum available, mu mg. Mu whatever according to the surface. Okay. So this is the maximum value. So this is the maximum value you can rotate with. Okay. So what will come? Mu V max. You have to remember this. You will be able to remember when you will see this kind of formula more and more in this step. Now only in this topic only. So V max is how much? Under root mu g r. Okay. Why this is V max? What happens if we go more above this speed? Then what will happen? Then what will happen is that your friction available is what? Mu mg. But you are saying I require more. That is not available. So what will happen? Slip. You will slip outward. That's what happens. Okay. If you go with more than a certain speed, then you will slip outward. Okay. So that's what will happen in the flat road. Okay. Bank road is little bit different. So this is what. Okay. And if the road is smooth, you can't rotate. If road is smooth and flat, you can't rotate. Why you can't rotate? Because there is nothing to rotate you. Because for rotation you require a force. Okay. That is not there. Okay. So that's why. So if it is friction is there, then only you can rotate in the flat road. So if you want to do a safe rotation, okay, then your speed should be in between, in this range only. Greater than 0 obviously. Okay. And less than under root mu g by r. Mu g r. If you go more than that, then what will happen? Slip. Okay. So that you don't want. So you want to go in this range. If it is a flat. Okay. What if I don't maintain the constant speed? I want an acceleration, like while rotating I accelerate the vehicle, or I de-accelerate, apply the brake. Okay. Then what will happen? Then understand that while you are rotating on the circle, if you are accelerating, let's say, okay, so how many accelerations you require? You require m into ac this side towards the center. Okay. And you are accelerating along the circular path. That means you require m into at. Tangential acceleration you require. That's what you are saying, right? So M into AT also required. Who will provide this both? Friction. Who will provide this both forces? Friction only is there around the surface. Okay. So friction have now two works to provide M into AC and M into AT. Earlier it was having one only, MAC. Okay. Now we have MAC and MAT both. So this will be friction value. Now this is how much mu mg maximum available, right? So that's why we say when you are rotating on a circle, right, that time you maintain a constant speed. What you do? Maintain a constant speed. Otherwise, if you apply a brake while moving in a circular path or you accelerate it, you will get a little bit disbalance. Okay? Okay? Why disbalance? If you increase your speed and let's say your speed exceeded the limit, your vehicle will slip during that time. Okay? Okay? So here two things are there. One thing is it should not exceed this much, but in this range it is not. Here M into AC value will be very low because you require MAT also. So here AC value is not this much, this thing. Okay, you have to go with a lower speed, but like let's say here we find out this is 60 km per hour. Highest you can go with the 60 km per hour. But here you can't even go with the 60 km per hour. Okay, even you can't go with the 50 also. Why? Because here you are going with 50 km per hour. This is okay. This is in the limit. But this came na. You are accelerating also, right? So your mv square by r is not there. Here this is also, and this is mu mg maximum available, right? So maybe this is out of the range. Combination is out of the range, right? So that's why. That's why while rotating, you maintain a constant speed and under the limit. Then you will rotate safely. Okay, and obviously it should not be out of the limit. Okay. So here just you have to remember that friction will have two works while rotating in this circle. Okay. What? M into AC and M into AT. Remember, if he is deaccelerating, then MAT will be this side. Okay. If he is going like this, okay, along the path, then MAT will be opposite. So net force is this side. Got it? Sometime he asks this thing. Okay, that what is the direction of net force? You calculate MAC and MAT this side, net force will be that direction accordingly. Understood? Okay. Got the point now? Next. On banking road. So on banking road also we will study now two things. Here you can take the smooth case also. Why? I will tell. What diagram this is actually is, you have a bank road, okay, so your bank road is like this and vehicle is going inside, and I cut the cross section of the road and I'm seeing from this side. Okay, road is outward like this and inward like this. Okay, going like that. Okay, so this road is like this in a circular path. Okay, not like this, you draw it like this. Okay, so currently he is following a arc of radius r, let's say. Understood? Okay. Now, how many forces are acting on the vehicle? Accordingly, we will see. We are saying frictionless, first of all. Friction will come, things will change. But before friction to understand, we have to understand the frictionless. Okay. So, on this frictionless, how many forces are acting? That we want to understand. Now, see. How many forces will act? First of all, who will act? We have seen the bowl case just now, right? Like that only. How many forces? Normal this side and mg downward. Anything else? That's it, right? Normal this side component is providing the centripetal force and normal this side component is balancing the mg. Then only it will rotate. Friction is not there. Okay. When you will study the bank road, after that you will study in the bowl also how friction can help. Okay, that you will understand there. But here currently understand that normal this side component will balance the, provide the mv square by r to rotate him in a circle, and normal this side component will balance the mg. So normal this side component is what? N sin theta. Everyone agree? So n sin theta is providing you the mv square by r, whatever radius he is rotating in according to the radius of curvature of that particular road. Okay. And second thing is n cos theta is balancing the mg. This understand the n sin theta how came? From here, this is a z, right? Theta, theta, 90 minus theta. So n sin theta will come. Okay, divide both of them. Okay, divide what came? Tan theta. So mg this side multiply. Mg tan theta is equals to mv square by r. From here v came how much? Under root rg tan theta. Right? Okay. Previously what was there? Mu rg tan. Mu rg. Okay. So like that there will be one more formula, you will understand. Wait for it. Rg tan theta. Okay. So this is the v. Okay. Now what will happen if I increase this v? And what will happen if I decrease this v? Why should I go with a constant speed? We are getting a constant value. What if I increase the v? What will happen? You tell me, if we go higher than a speed, then which side you slip? Outward or inward? Outward simply. You can answer like that, right? If I go with higher speed, I will slip outward, right? If I go with lower speed, I will slip inward. Why? Because the friction is not available, that's why. Okay. So here if I say that this I go V less, right? Then you don't require the n sin theta full component, right? You will not use it properly, right? If you go with the lower speed, you will not like you can say utilize it completely. Okay. And there is something remaining that will make him slide down. Like this you can understand. Or when centrifugal force will come, that time it will be very easy to understand. Okay. So currently like this understand, if you slow down, you will slide down. Okay. And if you fast, you will slide outward. Okay. Understood? In the terms of centrifugal force, we can say easily, but I will not explain by that thing. Okay. So this side n normal, this side mg, this side n cos, n sine and n cos. Okay. So n cos theta is balancing the mg. Okay. But n sine theta you don't required properly. So it will slide down. Understood? And if you increase the speed, then your n sine theta is not enough. Right? Because theta is constant, normal is constant equal to this normal is constant na here. Okay. Mg by cos theta. So normal is constant. And cos theta is balancing there. Okay. So currently when he is rotating, mg by cos theta will come, generally mg cos theta. That's a different case. Okay. So here what will happen? This is not sufficient enough, so he will slide out. Your n sin theta, like let's say you are holding with a stone and you are rotating it, but you are not holding it properly. What will happen? He will go out. Okay. Similarly, if n sin theta is not enough, then he will go out. So if you increase the speed, your requirement of the centripetal force increased, but he was constant only. So what will happen? You will go out. Understood? Like that. So what we are saying is, if your speed is greater than under root rg tan theta, right, then he will be slide outward. This we will use. That's why I am writing. Okay. And if your speed is less than under root rg tan theta, then he will be slide inward. He will fall inward. You can say inward. Inward is spelling correctly? Okay. Like that. Okay. Now come to the friction. Okay. Friction part. Understand now. This is very important. A little bit changes also. So if we use like this. Okay. See here. Same kind of radius thing. Okay. Same going inward, but the friction is available. How? Okay. And friction coefficient is what? Mu. Okay. So friction will be how much? Mu into normal. Right now? Okay. So here we say that if let's say you are going with a certain speed, if you don't want to use friction, right? Let's say friction is available, but you don't want to use the friction. Then what you do? You go with this speed, rg tan theta. And friction will be available, not available, doesn't matter. You are going with this speed, no problem. Okay. But if let's say you increase the speed, okay, I want to calculate the maximum speed available and the minimum speed with which I can go on that circle. Okay, like let's say you are on this surface like this, right? If you don't go fast enough, you will slide inward, you will fall. Okay, and if you go high, you will go outward. Okay, but what is the maximum value I can go? Because now friction is available. So what will happen is, as you will increase the speed, what is the tendency of going? Which side you can go? Which side is possibility of going? Outward, right? So as if I increase the speed, I want to find out here Vmax, velocity maximum available, right? So as I increase the speed, I have a tendency of going outward, right? So which side friction will act? Inward. Okay, you have a tendency of going outward, so you will act inward. Now you have three forces: normal this side, friction this side, and mg downward. And friction, if you want to find out Vmax, then you use maximum amount of friction. What is maximum amount of friction? Mu into normal. Mu into normal. So here now, towards the center force, that should be equals to mv square by r, and in vertical direction forces should balance. Okay, so that equation we will write down. That's it. So now, if you want, we can divide the components here also. Okay, so friction, these are the original three forces. Okay, now let's divide. So this normal force this side, how much? N, just now you wrote N cos theta, N cos theta. And this side will, what will come? N sin theta. Okay, friction value this side will come what? F cos theta. This is theta na, this is theta. So this one is theta, Z na, the theta theta. So what will come? F cos theta. F cos theta. Let's mark this theta. And this side what will come? F sin theta. And friction is obviously mu into normal. Okay, and normal we will find out here. So in vertical direction forces should balance. Okay, so what we can say, N cos theta should balance the mg plus f sin theta. Okay, this is equation number 1. Okay, and friction value also you can put mu into normal. Okay, so let's put here only, let's not mark it. N cos theta equal to mg plus mu into normal into sin theta. This is equation number 1. Okay, this side net force should be equal to mv square by r, and v will be Vmax because I am using the maximum amount of friction. I want to find out that highest limit with which you can go, because now if you increase the above the Vmax, if you increase, then friction is also not sufficient to stop you. Then obviously you will slide out, right? Because friction now it will switch to kinetic. Okay, you use the maximum amount of friction. Now still you want to increase the V, then it will be kinetic friction. Okay, so now write down the second equation, net force towards the center. That will be N sin theta plus F. F is what? Mu into normal. Cos theta is equals to M Vmax square by radius, let's say R. Okay, how many variables we have? Just what you do is, from this equation normal you calculate, put it here. Answer came. Can you do this? Huh? See, let me put. This is equation 1. This is equation 2. Equation number 2. So let's solve first here. What you do is you bring this n this side, or you take this, bring n this side. So n will come what? Cos theta minus mu sin theta, and then take it that side. So mg divided by cos theta minus mu sin theta. This came. Okay, this normal value you put here. Okay, what is there? Sin theta plus mu cos theta. Okay, and that will come what? Mg cos theta minus mu sin theta. Put the value. So here you can put normal sin theta plus mu cos theta is there. Okay, multiply by mg divided by cos theta minus mu sin theta equal to mv max square by r. Okay, can we get the Vmax from here? Is there any problem? mu sin theta, mu cos theta, mu into normal. Okay, correct. Tan theta, V max. Okay. So what will come from here? If we solve numerator mu cos theta. Why mu cos theta is there in numerator? Cos sin cos V max. M cancel out. V max will come how much? Under root GR. Okay, and then you will have this mu GR was there, na? Like that there will be. Okay, so RG tan theta. Mu cancel out. See here what is there? Sin theta plus mu cos theta in denominator. Cos theta minus mu sin theta. M cancel out R this side. Sin theta plus mu cos theta. So sin theta plus na. I will tell the trick to remember also, don't worry. Mu cos theta and denominator what? Cos theta minus mu sin theta. Right or wrong? Cos theta minus mu sin theta. Okay. This is what V max. Okay. Now in the same figure we will calculate the V minimum. Okay. Now as in the normal case you come to this case. Okay. If I decrease the speed, what will happen? He will fall inward. But if I decrease the speed, who will support me? Friction. Friction will not let me fall inside. Why? Because he will stop the relative slipping. I have a tendency of slipping inward. So friction will act outward. Agree? Okay. So now calculate that thing. So what we are doing is that same case. In this friction outward, because we want to get the V minimum. Okay. Normal this side, mg downward. Agree? These are the three forces. Angle theta given. Now what you will do? Divide the forces towards the center and perpendicular. Right? So this component this side how much? Normal. 3 times you wrote n cos theta. And this one this side n sin theta. Friction component upward F sin or cos? Sin. F sin theta. Why F sin theta? Here horizontal line draw theta theta, right? This side cos theta, that side sin theta. Like this, direct. I told you this. F cos theta. Okay? These are the forces. Only yellow marked in the mg you take. Okay? Because normal and friction already divided in components. Don't think like this. The component is also in this also. Already divided that force, right? So now net force towards the center. Center is that side, okay? Is following curve path like this, going inward. So we can say net force towards the center will be how much? mv square by r. That's it. So what is that? N sin theta minus f cos theta is equals to mv square by r. Here V minimum we want to find out. Okay. So if we want to find out V minimum, then we will use the friction maximum, right? Because I will reduce my speed. So friction I will use maximum possible. So what is that? N sin theta minus mu into normal, right? This is one equation. Another one, this side forces balance. So what is that? N cos theta should balance plus F sin theta. F is what? Mu into normal sin theta should balance the mg. Okay. Okay. From here, see this from the second equation. Calculate the normal value. Put it in the first equation. Okay. Normal is how much from here? Normal common cos theta plus mu sin theta. So what will come? Mg by cos theta plus mu sin theta. Okay. Correct. Agree na? What we are doing? Net force towards the center equals to mv square by r. Here friction is, he have a tendency of slipping this side, so friction will act that side. Okay. If you decrease more than the what value we will calculate, then after it will fall. Then friction is also changed to kinetic. Okay. So now understand. This normal value put here. So normal take common, what is remaining? Sin theta minus mu cos theta. So sin theta minus mu cos theta is there already into normal. Normal is what? mg by cos theta plus mu sin theta equal to mv minimum square by r. Here if I see, so mm cancel out, rg same, okay, and then you have sin theta minus mu cos theta. So v minimum is what? Under root of rg, then what? Sin theta minus mu cos theta divided by cos theta plus mu sin theta. Okay, this is the minimum speed. Now the thing is how to remember these values, maximum speed and minimum speed. Okay, we can remember easily. How we can remember easily? If we can remember this thing, rg tan theta, under root rg tan theta. If you can remember this, then you can remember both of them also. We can remember this, or we can solve this simply, right? Horizontal and vertical, that's it. This side force equals to mv square by r, and this side force balance. Rg tan theta came, okay? If, now tell me, if I put here in this formula, if I put mu 0, that is the frictionless condition, right? If I put mu 0, what is coming? Rg tan theta, right? Correct na? Mu 0 Rg tan theta, sin by cos tan. If you put here also mu 0, what is coming? Rg tan theta, right? That is the one thing. Another thing is what you have to do. Now compare both of them. He has sin theta in numerator. If I want to create a tan theta, that I know Rg tan theta, I am telling the trick to remember, okay? Rg tan theta. Tan theta for what I required? Sin by cos. So numerator there will be a sin, denominator there will be a cos. Okay. If I want V max, so I should have a addition in numerator and subtraction in denominator to increase, right? To increase, addition in numerator, denominator, subtraction. Okay. With sin there will be a cos. With cos there will be a sin. Okay. And how will I remember? That I have to put mu 0. If I putting mu 0, is it coming same? Yes, that means correct. Okay. 2-3 things you have to remember. One is for tan theta sin by cos. Okay. With sin cos will come, with cos sin will come. Okay. And minus will come in denominator. Why? Because we want maximum value. And if you see here, he want minimum value. So subtraction from the numerator and addition in the denominator. Understood? Same tan theta sin with cos, cos with sin. Understood? Like this I can remember. So what I have to remember actually? Rg tan theta. And little bit of structure of this formula in the mind, so that I can rearrange the things. Now in any formula, if I put mu equal to 0, my answer should come Rg tan theta. Okay. And for the V max, numerator should be plus, and for the V minimum, my numerator should be minus. Opposite side on the other side. Okay. Got the point?